All right, we're looking at the 2.7 overview. 2.7, there's a kind of a, I don't want to say there's way too much to go over. What really I wanted to do with 2.7 is break it into two distinct pieces. And this video is going to give us some common language that we're going to be using in each one of those pieces. So these are the basics. Their goal here is to really understand the basics and get some of the vocabulary when it comes to graphing quadratic equations or quadratic functions. All right, so first things first, let's take a look. All quadratic functions, so quadratic functions are going to be in the form of f of x, this makes it a function, equals ax squared plus bx plus c. All right, so all quadratic functions, regardless, are in the form of fx equals ax squared plus bx plus c. This is the general form. And you're also going to be able to see this in the vertex form. So this is general, so let's call this general form. And then a look at the vertex form. We have f of x equals a times x minus h squared plus k. And what's really neat and what's really nice is that the a here and the a here are the exact same a. Now we got to do a lot of molding and mending to shape the bx plus c into these h and k thing or whatever. We're going to dive into each one of these a lot more in separate videos. So let's get some common language here. The shape of the graph, it's either going to be opening up or it's going to open down. So this one opens up, this one opens down. And there's some key characteristics with each one of these. All right, this point way down here, this is called the vertex. And it's always going to be the coordinate point, x comma y. It's always going to be the point h comma k. And over here we have a vertex in the form of h comma k. That's our vertex there. And what's really, really, really nice about every single parabola, and these again are called the shape here. So the shape, it's called a parabola. Every parabola has this really, really unique feature. And it's this line right here, and it's imaginary, that's why I put it dotted. We don't always draw the line, but there's some symmetry here. If I were to fold this piece of paper over the dotted line, each one of these points would match up with each one of these points. All right, so this dotted line here is called the axis. So the axis of symmetry, symmetry, symmetry. All right, so that's this dotted line here and here as well. Oh, excuse me. So this dotted line, right, it would always be that line. And the axis of symmetry for graphing quadratic functions is always going to be in the form of x equals h. All right, well, h is my x coordinate here. And this is the vertical line that goes through the x-coordinate. So the axis of symmetry is going to be the form of x equals h. All right. So what makes a parabola open up? So let's write it like this. The parabola opens up if a is a positive number. All right. So a is greater than 0. This is a way of saying positive. And conversely, the parabola opens down if a is less than 0 or a negative number. Right? And really, that's the main form of the language that I want to get into. In our next video, we're going to take a look at the general form and how can I graph a quadratic in the general form. So we're going to take a look at that. And then the video after that, we're going to look at how to graph it in vertex form.